right, good morning, everybody. Great to be here with you. I'm Jonathan Gifford. I know many of you, and so thanks for being here this morning. I'm a professor here in the Schar School of Policy and Government at George Mason University, and also the director of the Center for Infrastructure, Public-Private Partnership Policy here, which has been around, I think this is now our 12th year. So I'm delighted to welcome you with us today. So on behalf of the president of George Mason University, Greg Washington, and the dean of the Schar School, Mark Rozelle, it's a pleasure to welcome you to our 13th Policy Forum. So we have a long history of infrastructure research and education here at George Mason. Our center focuses on what's necessary to make best use of every dollar that we spend on infrastructure, and we think P3s should be a part of that where it makes sense. You know, we're not advocates for P3s, but to try to give a fair assessment, an objective evaluation, and we try to support that through research, through education, and outreach. I owe a special note of thanks to our sponsors this year, our forum partners, Transurban and I-66 Express Mobility Partners. We have a couple people here from Express Mobility partner Ruben and Nancy Smith. Thank you very much for the support. And I think I haven't seen anyone from Transurban, but we have a few people due here in a few minutes there as well. I think the traffic and the weather have conspired to sort of slow the inward flow here. So we should see more people showing up over the course of the next hour. And we also have three sponsors here. We had to get our sponsor slide up here on the board before I started, but breakfast sponsor is Nossaman. So we are enjoying their breakfast courtesy of Nossaman. Plenary is our lunch sponsor a little bit later, and then Nexco West is our reception sponsor. So we have guests here from Nexco West as well. So thank you all very much. I think we really couldn't do the work we do without them. It helps us, present this meeting without a registration fee and to feed you, but it also, more importantly, supports the great work that we do and the students that we're able to support in our activities here in the center. So please join me in thanking our sponsors. We also provided a card, on how you can support us if you care to when you checked in. So please, if you have any questions about that, Nicole, who's at the front desk, or I would be happy to talk to you about that. So a few quick thanks and introductions to our students. Mustafa Sever, I think, is also out at the registration desk. One of our PhD students who is interested in operations and maintenance of P3 processes and has also been the program manager in our center. Marina Manganares has recently returned full-time to student status after a stint at USDOT, and so she's very interested in electric buses. And Cindy Quiros is going to be here, I believe. I don't see her here. And Valentina Farias, I presume, is somewhere on I-66 coming in from Fairfax at this moment. But she's a civil engineering student interested in toll setting. So I'll reintroduce them at lunch, and I think encourage you all to take the opportunity to talk to these brilliant students and who are such an important part of what we do here at the center. So our forum theme this year is Next Gen P3s, Infrastructure at the Intersection of AI and a New Federal Policy Landscape. We'll have panels across these three themes today and a keynote address at lunch by Ruben Roman, who's here, the new CEO of I-66 Express Mobility Partners. And to kick us off, I'm delighted to welcome our first panel on infrastructure and AI, digital resilience, enhanced safety, and beyond. The VDOT P3 Office Director, Faizan Habib, has been called to a last-minute meeting with the Secretary, and so happily, we have John Yun Kwan, or JK. JK is a PhD alumna of our Schar School of Policy and Government. who did her dissertation on toll road policy a few years ago, did a short stint at Sintra, and then joined the VDOT P3 office a few years ago. And so we're delighted to have her moderating the session. And without further ado, I'm going to turn it over to you, JK, and the panel. So thank you very much for being here.
Well, thank you, Professor Gifford. I just wanted to thank GMU and the Center for Infrastructure Public-Private Partnership Policy under Professor Gifford's leadership for their continuous support and research in P3. As an owner, when we have any key major decisions, and we always go back to research in P3s for their insight. And, that's where we restart and, really establish the next steps forward. So I wanted to thank you, and especially for hosting today's forum on Next-Gen P3s. That is very timely and forward-looking. My name is Jong-Yoon Kwon, Deputy Director at P3 Office, Virginia Department of Transportation. Very happy to be here this morning, not as a student, but as an alumni. It's a very different feeling this morning. And I have to introduce VDOT to everybody here because it does give perspective and set the tone for this panel that we'll be discussing today. And if you're coming from other states, I think your experience and your feelings regarding these topics that we will be discussing today will be similar to what I feel here with our experts here today. So VDOT is responsible for building and maintaining and operating states' roads and bridges and tunnels. Let me give you a perspective from numbers. So our roads are 60,000 miles, 21,000 bridges. We have 6 tunnels. You'd see numerous traffic control devices and ITS system all over the state. We have 3 ferry systems, over 40 rest areas, and 100 commute parking lots. Virginia happens to be the 3rd largest state maintaining highway system in the country behind Texas and North Carolina. And our budget alone this fiscal year in 2025 was $8.9 billion, building and maintaining and operating these facilities. P3 program alone has delivered $20 billion investment to the Commonwealth. We deliver the most projects in the most congested corridors, usually located within the urban environment. And we also deliver critical infrastructure like Elizabeth River Tunnel and Hampton Roads Bridge Tunnel. So given this vast scale of infrastructure that are in place in Virginia, today's topic, this very first session, becomes very critical at this moment, which is titled Infrastructure and AI, Digital Resilience, Enhanced Safety, and Beyond. It is highly relevant and timely to Commonwealth public safety and health and our economic development. And considering last year's Executive Order number 30 that was issued and executed by Governor Youngkin, titled The Implementation of Standards for the Safe Use of Artificial Intelligence Across the Commonwealth, our interest is definitely out there to embrace these new technology, and we are ready for it. So we wanted to see what opportunities there are for us and for all these participants in this P3 industry, and see how we can embrace these changes in a very timely manner and not be behind all these changes that are coming for us. So I wanted to introduce 3 fantastic panelists today here from both industry and academia. Dr. Massimiliano Albanese is the director at Center for Infrastructure Security in the Era of AI, GMU. Congratulations for opening your center just April 2025. Look forward to your works. Alison King is the vice president in government affairs at Forescout Tech Inc. And Giridhar Srinivasan is the co-founder and CEO at InfraClear. So we will start our panel discussion with a self-introduction. We are very interested to know what you do. Can we start with Max?
Okay, thank you for the introduction. As you say, my name is Max Albanese. I'm a professor and associate chair for research in the Department of Information Science and Technology at Mason. The department is part of the School of Computing, which is under the College of Engineering and Computing. I'm also the associate director of the Center for Secure Information Systems. My main research interests are in the area of security broadly. And as she mentioned, we recently created this new center called the Center for Infrastructure Security in the Area of AI, which is very relevant to today's discussion. I'm going to tell you a little bit about this. Our long-term plan is to establish what is called an NSF IUCRC, Industry Cooperative Research Center. I've been involved in another IUCRC, which ended in August 2024, on cybersecurity. If you're not familiar with NSF IUCRC, that is a model that has been around for at least 4 decades, where NSF tries to bring together academia, industry, and government to solve problems that are of interest to industry and problems that can have a broader impact on society and community in general. So back in fall 2023, when we were about to wrap up our previous IUCRC, I came up with the idea that we should start focusing our cybersecurity research more on infrastructure, since, of course, as everybody knows, the number of incidents, cybersecurity incidents affecting critical infrastructure were on the rise. And also there are studies like the IBM cost of data breach reports that show that breaches of infrastructure, cybersecurity breaches of infrastructure components are much more serious in terms of cost than breaches of traditional IT systems. So there is a need to address this domain. Now, of course, as you know, the situation in the federal government is very fluid. So we're still going to pursue a NSF IUCRC, which means essentially that NSF puts some money in the center. But the money that NSF puts in this type of center is not to do the research, it's just to cover the administrative cost of running the centers. The money that is used for doing research projects that are relevant to the scope of the center come from industry membership. So industry partners provide a membership fee, which is ridiculously low, $50K per year. And that pot of money is used by the center to run projects that are of interest to industry. I can tell you more about this. Now, with the government situations being very fluid, and in fact the solicitation for IUCRC, which was due in, the proposals were due in June, now that's been taken down, and they are saying that they're going to issue soon another solicitation. So it's a moving target. So to be resilient, what we decided with the support of our VP for Research, Hunter Marshall, and the Dean of the College of Engineering and Computing, we decided to just go ahead and create a center as a research center under College of Engineering and Computing. And if we're successful to get also the NSF funding later when it becomes available, that's good. But otherwise, we'll move on because there is interest, there is momentum around this topic, and it's just the right time to do it. And with that, I want to wrap up my initial remarks.
Thank you, Max. Alison, do you want to introduce yourself?
Sure, if I can. Is this working? Okay, perfect. Well, good morning. It's a pleasure to be here. I am an alumni twice over, and I always had anxiety coming into this building because I was heading to class, and now, it's kind of shifted now that I've been in business for quite a bit. I spent 14 years in the federal government, and I've been in private sector for almost 3 years now. And the majority of my time has been focused on national security, but in the last 7 years, I shifted over to cybersecurity. And I'm delighted to be here because the threat landscape that we see today is evolving at an accelerated pace. The AI piece just ensures that things continue to evolve at a rate that none of us are really prepared for. And so it's essential moving ahead, especially within this space, this industry, that there is an understanding that mandatory cybersecurity engineering standards for new builds are going to be really important because anything that's connected to the internet or has the capacity to be connected to the internet is a target by state threat actors. And we've seen this with CCP pre-positioning across our critical infrastructure under Volt Typhoon. About 2 years ago, for the first time ever on Capitol Hill, we had 4 principal cyber directors testify discussing this threat. We had the FBI director, the director of CISA, we had the national cyber director, and then we had General Paul Nakasone, who was then NSA and U.S. Cyber Command, having this discussion. And it gets pretty sinister because there is no espionage or economic value to pre-positioning across critical infrastructure, whether they're hospitals, water systems, transportation systems. The health and safety issues that can happen are pretty significant. And so moving ahead through P3, leveraging AI in an ethical and responsible way, it very much is a tool for us to be able to expedite all the necessary safety and engineering considerations that need to be in place. So over the lifetime of these new builds, they can manage an acceptable amount of risk. So thanks again for the invitation to be here. It's a pleasure.
Thank you. Giridhar, you want to go ahead?
Sure, yeah. Thank you to Professor Gifford and to George Mason for having me. I'm Giridhar Srinivasan. I'm a co-founder and the CEO of InfraClear. We have built something like a Google for infrastructure data. I spent about 15 years developing and financing infrastructure projects around the world. Spin the globe, stop it, may have been there, developed a project somewhere over there, probably unsuccessfully. About 6 years ago, we started a company with the view to basically making data on infrastructure projects widely available. And it started with the simple premise that I was getting frustrated that every time I tried to develop a project, you'd spend years and years trying to go and develop a project, and you'd say, well, gee, that project looks a lot like what I thought it should be, and it looks like the last project I developed before. But why don't we have the data on what's been done before? Because then we could have spared years and years of developing the project, because we could have replicated what worked before. So the simple premise was to say, let's go and gather the world's infrastructure data, index it, and then make it easy to use. Simple idea, hard to execute, but we did it. And we've gone and gathered about 200,000 signed agreements covering about 130 countries around the world across different infrastructure sectors. And we've used a series of tools to be able to go and extract data on prices, terms, and conditions. So for the first time, you know who did what at what price and on what terms. What did Bechtel do on the Corpus Christi LNG project, and how does that compare to what they did on the Rio Grande LNG project? Or what did the Chinese do, speaking of CCP, what did the Chinese do, on what terms do they go and buy lithium around the world? Or for transport projects, what are the differences between force majeure clauses and events of default clauses across 50 different projects? And the reason why I'm here on a panel on AI is, as somebody who's gone and implemented AI-based solutions, we started with natural language processing-based solutions before this. And it took us a year and a half to go and annotate 7,500 agreements by hand and correct that and build a training data set. It took 20 engineers to do that. Today, we can process 100,000 agreements in a month with 1.5 engineers. We're 4,600 times as productive as we were thanks to the use of AI. And we see many applications for this, which we'll talk during the panel. So I'm coming from the world of people who've started to use AI, perhaps with success, hopefully cognizant of the threats also that Alison laid out. But I see is extraordinary potential in applications for infrastructure.
Thank you. I wanted to start off with the question, understanding the key terms that we are discussing in this panel. So one of the keywords that stands out to me in the title is the digital resilience. Many of us sitting in the audience probably are from infrastructure. I'm guessing that you are from infrastructure space. And in the infrastructure space, we talk a lot about sustainability, resilience. So I'm guessing vaguely that there is some relationship between two concepts, but I really wanted to hear from the you who are actually practicing these every day and understand how you define digital resilience and think how AI and cybersecurity relates to this definition of digital resilience.
Maybe I'll start with the first thing, which is talking about resilience, and I'm least qualified to talk about cybersecurity, so I'm going to be in active listener mode here. We built a fund for resilient infrastructure at IFC, and the sustainability, the way I think about it in layman's speak, is sustainability is that optimal state of equilibrium that you're trying to get to, right? We define it how whatever balance, environmental, social, citizen, contractual balance. And resilience is simply saying, well, gee, stuff happens. And so you're going on this trend line and boom, you get knocked off course. How do you bounce back? And resilience is really about, as the Rockefeller Foundation very articulately talks about it, it's about anticipating what might happen, being aware of it, planning for it, trying to build capacity in early on to be able to then go and bounce back to whatever desired state you may want to be at. So if it maybe to get you back to that path of equilibrium, which is that path of sustainability. So I'll stop there, and I think panelists can talk much more about that.
I can take it from there. So there is a very, commonly accepted definition of cyber resilience provided by NIST, which is very close to what you just described. And it is defined as the ability to anticipate, withstand, recover from, and adapt to cyber threats. So let me break it down. Anticipate, as you say, you need to understand what your risks are. You need to understand what your adversaries are and what target they may go after so that you can plan to protect those assets, to anticipate, to prepare for those kind of threats. Then the second piece is withstand. So you know that no matter how much effort you put into anticipating and trying to prevent incidents, they will eventually occur. Eventually, your systems will be under attack. So you need to have the ability to continue functioning while you're being attacked. And third is recover from, which means that no matter how much effort you put into the two first steps, there may be some situations in which your preventive measures fails, you're not able to sustain the attack, you will sustain damage from the attack, you have to recover the functionality of your systems quickly and go back to that desired state. And then the fourth component, which is adapting, it's sort of transversal to all the others because, in a sense, the cyber landscape changes over time, and by continuously learning, you get yourself the ability to change your defenses based on how the landscape around you evolves. So it's a continuous learning process that cuts across those other three steps. So this is, the most widely accepted definition of cyber resilience. Again, it's provided by NIST, so it's sort of, well recognized in the cybersecurity community.
Sure. So I'll go ahead and just kind of like pull all of that together a little bit. How many of you, and this is like a really silly question, are engineers in this room? And how many of you, part of your curriculum had cybersecurity or digital threats? So that's something that we're all trying to rectify moving forward. So you're all lifelong learners. That's the reason why you're here, is there's a recognition that things continue to evolve and you want to be in the best possible position to be able to take advantage of the opportunities and also recognize the threats and plan accordingly. And so around resilience, and they all had very good comments for you on this. In the United States, there are 16 critical infrastructure sectors. There's a lot of chatter about how there should be more to include space systems and potentially cloud, but we have not gotten there yet. But ultimately, in all of these, there's a recognition by the federal government that then permeates into the states and the Commonwealth here that there are services essential to modern life. And so all of the investments that go into our infrastructure, whether they're the built environments and the institutions that we have that provide a critical resource to the community, needs to be maintained over time. And so given that we are in this new environment where the digital threats that have always existed are being amplified at accelerated rate, the resiliency piece has to be understood just quite commonly as your ability to get up off the campus. So what does that mean in terms of being able to ensure that new buildings moving ahead or buildings that are going to be modified take in this consideration? One great place to start, although I think significantly more work needs to be done is around cyber-informed engineering. And so this is something that Idaho National Lab, in conjunction with CISA and the Department of Energy, have spent a lot of time and resources acknowledging that there are some best practices across the board that need to be included in the curriculum for engineers moving ahead, because to date, you're being put in a position where it's becoming increasingly more difficult for you to be able to satisfy the health and safety requirements that you have for your projects moving ahead. And so I will kind of point you in that direction as a way to, kind of understand how to build that resiliency into the designs and constructions, and even like the maintenance surrounding some of these projects. And then the sustainability, again, it's just the uptime, right? And so there's a recognition that it's not that you won't encounter these issues, it's how you're able to ensure that you have a manageable amount of risk that doesn't impact your performance. So I would just kind of point you in that direction as well.
So I think that's a great segue to our next question, that how is AI and cybersecurity transforming or reshaping our infrastructure system? And when I say infrastructure, I'm more thinking of transportation network, energy grids, water system, digital infrastructure. These, to me, are infrastructure when I say it. And if you have other definitions of infrastructure, please share those too. So can you provide some examples how these are reshaping the infrastructure space?
Okay, so when I think of digital infrastructure more broadly, I think of two things, which is hard digital infrastructure and soft digital infrastructure. Hard digital infrastructure is, things that like devices, data centers, providing fundamental connectivity, storage. And soft digital infrastructure are the applications and software that makes existing assets function a lot better. A lot of us, I think a lot of the attention we focus on goes towards data centers. And that's just, capturing the popular imagination, certainly capturing investor attention. That's where the CapEx is. But I think the greatest gains are to be made with respect to the application to be able to go and drive capacity improvements over here. So what could we do? I'll sort of point out a couple of statistics and then point to a couple of other industries just to highlight the contrast. First number I'd give you, three numbers I want to give you. 90%, 75%, and 1%. 90% of projects that good developers try to go and develop never get to financial close. 50 to 75% of the projects that we do end up developing get renegotiated. That's a restructuring, people. I used to be a banker on Wall Street. That's a restructuring. That's a 97.5% failure rate. If Elon Musk saw a production line where there was a 95% defect rate, the factory would be shut down. The models that we use right now and the methods that we use right now must be deemed a failure. Sorry, that's the data to a room full of engineers. What does that result in? 70% of the mortgage market today is securitized. It means we have a liquid, transparent asset class post-global financial crisis. I used to work at Lehman Brothers. 1% of infrastructure loans are securitized. We're doing something wrong. So what's the opportunity over here? I'll just point to a few other innovations from other industries. We see the Human Genome Project. We see CRISPR. We see fracking. We see imaging for fracking. There's so many other innovations that have taken place in other industries. We need to ask ourselves, what innovations do we need to bring? What applications of those innovations could be relevant for infrastructure? So here's how I think about it. When we think about where we could make an impact, it's, everybody talks about ChatGPT. That's a model which runs on data, which requires computing power, for which people then need to go and build applications. So the greatest opportunities, as far as we're concerned, are in terms of the data and in terms of the creativity of people over here being able to go and understand what applications would solve our problems over here. Number of examples we can go to, but I at least wanted to sort of lay out that framework, and I'll say a couple things. I think we have an opportunity to be able to go and bring more bankable projects to market based on data, based on prior precedents, lower capex cost, fewer cost overruns, automated dispute resolution. Today, your health insurance claims, most of them are just adjudicated by computer. So a lot less dispute resolution with construction. And I think we really have an opportunity over here to go and use the data on what's been done before to start to reconcile, standardize infrastructure projects, at least in terms of the contractual structure, and then be able to go and drive towards an asset class.
Okay, so before talking about the potential applications of AI, I want to do a little bit of a digression and ask ourselves, what is AI? And what is not? So essentially what we've been trying to do for not the last few years, but for decades. I mean, certain conferences on artificial intelligence have been around for 40 years. So our goal has been for many, many years that to try to mimic human intelligence into machines. Are we there yet? No, but in the last few years, we have made enormous progress. Now, going back, we're trying to mimic human intelligence. Then what is human intelligence? And there are, of course, many, many different possible definitions. There are people talking about different kinds of intelligence. But one thing that AI cannot do, at least not yet, is creating. Yes, we're talking about generative AI, but most of what we see as generative AI is just blending together things that this learning, the AI models have seen during training. Even if you think about AI-generated images, they're not the result of creativity or human creativity. They're not the equivalent of human creativity. It's just pieces of other images blended together based on understanding the prompt that you're giving to the AI model. So what I've always been saying, in several of other panels is that we need to think about AI as a tool rather than a way of replacing humans. So human intelligence is still superior to AI at the moment. Maybe 10, 20 years down the road, there will be, we will live in different times. But so right now, and we have done some work, and I'm doing some work with some colleagues from other universities on this idea of human AI partnerships, where essentially you have human doing their tasks and AI agents supporting those tasks by automating most of the, the most repetitive tasks, combing through tons of data to extract and see patterns that humans cannot immediately see, or maybe things that humans would be able to do with using, spending much, much more time. So that, as you pointed out, that increases productivity because the human can complete a task that would take 2 days in maybe an hour. Or you can complete the same task with one person instead of having a team of 20 persons. So that's where AI can help. Now, going to infrastructure, where we can see the potential for AI to support the work of experts. And, I can think of many, many different applications. One could be predictive analytics, predictive maintenance of infrastructure. Just one example. I mean, you're from VDOT, so, one of the things you have to do regularly for ensuring safety is inspecting bridges and roads to make sure that they are sound and safe to operate. How do you do that? How do you inspect a bridge like, I don't know, I don't have an example that I live in Maryland, so I cannot think about a big bridge. You would have to inspect the column, you would have to inspect different parts of the bridge. It would take crews of humans, days to walk through the entire structure. You could use drones capturing images of different parts of the bridge, throw them in a computer, process those images, and identify things that need more attention. And this would be taking just a few hours of a human expert just to go through that and then prioritize what needs to be inspected. Same thing, you could inspect the road surface with, a drone flying over the road surface to identify potholes. so you can send crews just where they need to go instead of spending hours driving miles and miles of roads with a team of 3 people to to inspect the surface. So these are some of the things where we can leverage the ability of AI to see things, identify patterns, recognize specific classes of objects, artifacts, in order to boost productivity. And of course, this translates into efficiencies, reducing costs, increased safety. I mean, there are broader impacts. It's not just about reducing costs, but if you think about it, by doing this predictive maintenance, you reduce the number of accidents that could lead to injuries, fatalities, healthcare-related costs, lawsuits, and so on. So it's not just saving money on the maintenance itself, but it's saving money on all the consequences that failing to maintain infrastructure in good conditions could have down the road.
J.K., could I just jump? Oh, I'm sorry.
Yeah, go ahead.
Could you maybe just explain to the crowd, the audience, the transformer model and just why that is so important in terms of ingesting all that data that you just talked about and how it makes an impact? I think that's at the root of it.
Right. So essentially, I mean, in a nutshell, the idea is that you give, the transformer model essentially tries to gets an input or let's say machine learning in general. What it tries to do, you give a data set, and machine learning algorithms are designed to essentially extract features. And of course, there is a difference between supervised and supervised learning. Let's say that, for simplicity, let's talk about supervised learning, where you provide an AI model or ML model a data sets of labeled data, where you say, these are 20 images of a bridge, and these images have these possible defects, okay? And then if you provide enough data, the algorithm can identify what features are dominant in samples that have defects and what features are dominant in samples that do not have defect. So then you give the AI algorithm or ML algorithm an image that the algorithm has never seen before, and based on the learning on that data set of many pictures, it can decide whether or not there may be a defect in that picture of a bridge. This is simply put. But this process, again, I mean, the human can do the same thing, but the AI can do it in fractions of seconds, and that's the advantage.
Sure. So I'll add a little bit of my own commentary here. So AI is not a magic trick, although a lot of people consider it witchcraft depending on who you're talking to. But even in the corporate world where I'm currently in, and our economy is built on services, there's a running joke. They say AI is corporate Ozempic. And so there are certain places where it'll allow you to reduce headcount, but it wholesale will not replace a trained, qualified person. So always kind of keep that in the back of your mind, that you don't have to fear out of the gate losing, your job to AI, but you will lose your job to somebody who knows how to leverage AI. So looking to apply that correctly and ethically in this context is going to be really important, because there's 3 things you always need to consider. You need to know that you need to ensure that you can have clean, quality data, because garbage in is garbage out. You have to be able to secure the model, because that creates a honeypot where you'll have people who will see this and will want to either take it from you. There's ransomware issues around data models, or they want to poison your data set to sabotage your work. And then you have to train the users. So all of this is just a new tool that you can leverage to be able to do your work so much faster. And then the day you have to always check it. You have to be smarter than the tool. I use it every single day. I've completely cut out Google and any other search engines, because I don't want to ask a question and then it vomit 50 different things all over me that I have to sift through. So I've gotten a lot better at being able to do prompts into it, and then also ask, okay, now give me the resource, because I'm ultimately responsible to making sure that the information is correct, and that when I leverage this for my own work, whether it's writing congressional text or looking to be able to dig into somebody's systems and threats and planning that everything that I have, I can back it up, and that helps me personally with like the early stages of design. And fragmented data that we all live with, limited cross-discipline integration, all of that, you can kind of pull it together a lot faster. So you're in a position where you can say, okay, let me do this fine-tuning because I didn't have to spend 6 hours doing all the push-ups or being disaggregated, more broadly speaking. So what are the things that are ripe for disruption in terms of being able to streamline the design piece? We talked about making sure that you had access to what already exists so you can kind of run your own models and kind of figure out like what your regression lines are that will fit within your time, your scope, and your budget process. And so I think that is a great use of it. And again, it all comes down to you understanding that this is just a tool. It's going to help you work more efficient and faster. And as long as you don't abuse it, I certainly see there's a lot of opportunity to be able to shift the traditional cost centers around something that you can then angle towards greater investment.
Right, and since you talked about data quality, one thing that I want to add is when we talk about resiliency, then we need to, and resiliency of a system that is using AI, we need to add the AI part of it as part of the resiliency equation, because that essentially extends the attack surface of a system. Traditional systems that don't use AI can be attacked in many different ways, but now if you have a system that uses AI, that system can be attacked by, for example, poisoning the data, which will be a very subtle way of attacking the system with minimal chances of being detected. So the data quality when you're using AI becomes very important, because AI decisions or AI-driven decisions are based on that data. And one interesting thing that is happening is, if you think about LLMs, they've been trained on everything available on the web, mostly. But more and more, the content on the web is AI generated because people build websites using LLMs to generate parts of the content. And now what is going to happen over time and over the years, LLMs will start feeding themselves on their own output. And that is going to have some very interesting consequences for the quality of what is going to be the output of future LLMs.
So both Alison and Max had a foresight and already addressed the question that I was going to ask the next, which is what strategies are government agencies like State Department, Transportation are using, or what strategies should we implement to integrate AI and supporting security measures into our planning and operations. And I think, Alison, you're emphasizing the data quality, and Max, you also emphasized that, but training and building the institutional capacity to sort of embrace the new technology, I think you're emphasizing those importance of those. How about the stakeholder engagement? It does require additional resources, for example, for state government to embrace these new technology and start training people and integrating these systems into the hardwired infrastructures or soft infrastructures. So it does require significant legwork to talk to our stakeholders and have them completely on board before we can actually implement these strategies. So how do you recommend, what strategies would you recommend government agencies in particular regarding stakeholder engagement?
Would you like to go first? You want me to go first? Okay. So if this seems like a novice place and you don't know where to start, the federal government is in a very similar place. So under the Biden administration, we had an executive order, and for folks in the room, an executive order, they're very common amongst all presidents, and it's a way for them to try and expedite their political agendas without having to go through the gridlock that is Congress. Congress was designed to be a gridlock, even though it doesn't always seem like that these days. But the running joke among the policy community, which I spend a lot of time in, is that the executive order on AI that was released under the Biden administration was written by an AI engine because it sounded like an idiot savant wrote it. It was really difficult to get through. It was really dense, and it was just kind of a joke because it was also like well over 100 pages. So they won the award for being able to leverage the technology. But that document was meant to provide direction to the departments and agencies on how to leverage the technology in a safe, useful way, which is essentially appointing someone to develop policy and then give them resources accordingly to be able to integrate it throughout the authorities that every department agency has moving ahead. But given that we have shifted into a new administration, we are yet to see what is going to happen. And so that AI executive order was revoked by the Trump administration. So we're waiting to see what the new direction will be moving ahead. Currently, we're waiting for the president's budget to drop by the end of the month. And that really will provide us greater insight into what the goals and objectives are moving ahead. Also, it'll be interesting as well because JD Vance about 3 months ago went to the AI Paris summit, and while the Europeans doubled down on regulations and really wanting to understand the technology and taking a measured approach, JD Vance says we're not going to do that. This is a new technology. We will augment it as necessary, but I really want to be able to leverage it because there is a belief in the national security community that this is a pivotal movement for us, just like with the internet, and whatever country is able to harness the new technology in key sectors to be able to produce growth year over year, which hopefully will put you in a position of establishing a monopoly, will be the new global superpower. And so the competition piece is pretty fierce amongst the United States and the Chinese Communist Party at the moment. And so we'll see what that means across the larger federal executive branch. It's still, for a lot of folks who are kind of part of the bureaucracy, a buzzword, but outside of their government responsibilities and the systems that they're allowed to use, they're in a similar situation where you are today. It's like, how can I be comfortable with this? How can I use this in my own personal capacity so I can be in a position of how to leverage this tool professionally speaking moving forward. Yep.
Thank you. I had 15 questions, and I think I only covered 3 or 4 so far. But I wanted to ask this question before we close out. What role does the private sector play in providing AI or cybersecurity solutions to federal and state infrastructure agencies? Beyond the role of the service provider, do you see opportunities for some innovative public-private partnerships driven by AI or cybersecurity solutions? Any examples would be fantastic.
I am shocked by the lack of understanding among sophisticated infrastructure professionals of the fundamentals of technology and AI. And for a long time, that was, that's the IT department. And I think that if that persists, you will quickly segment the market between, as Alison was saying, alluding to, haves and have-nots, people who know how to use this technology and people who don't know how to use the technology. I think that I'll make a macro observation to answer the question that you posed, and then maybe just go back to something that Alison was saying, which is that I think that if you operated a road in the middle of the United States, you weren't really too worried about the world outside as to what was going to happen. But as Max was saying, the attack surface right now with AI is so much bigger. So you are certainly vulnerable to a cyber attack, no matter where you are. I don't think, while there are individual private companies who develop the applications to be able to go and help meet threat needs, I don't think companies as a whole are prepared to be able to go and deal with fundamental cyber defense issues. So I think as a necessity, I think that you're going to see through fits and starts, and probably after a couple of crises, you'll probably see companies, infrastructure companies, start to work far more closely with governments. And so I think this is actually a different kind of partnership that you're talking about. I would not be surprised if in the future you saw a cyber defense tax or something like that, some kind of levy assessed on assets, simply because it's going to be needed. Cyber insurance, if you've ever looked at a cyber insurance policy, not worth the paper it's written on. It's a waste of premium. So the only resort is to be able to go to a government, and so I think you have to be able to go work with a government in this space. So I think that this is a new era for partnerships, and I don't think the companies have quite realized that. I just wanted to go back to something, though, if I could, which is just about what you should do to prepare or just learn about this. Oh, sorry, Max, you go ahead.
Oh, go ahead. You finish.
So I think that to understand, I'll address just comments to both professionals and perhaps a few students who are here in terms of how to get prepared for this. One is I think the transformer model is shocking, and there's a famous paper called "Attention is All You Need" that was written by the Google scientists. Worth reading the annotated paper, the Idiot's Guide to, or for that paper, because I think what it talks about why AI is almost human-like today in its intelligence. It understands the context. It doesn't need labeled data. It's shocking. It's really worth understanding how the transformer model works. And then in terms of thinking about the application, the paper I always read carefully and go and reread is a paper by the Asian Infrastructure Investment Bank on a digital infrastructure sector analysis. And despite their antecedents, I think it is a phenomenal piece of work on mapping out hard digital infrastructure and soft digital infrastructure in terms of the opportunity. It is a must-read. It's 100 slides, but it's gripping reading. I really mean it. It's gripping reading. In terms of just for the students in the room, I'll just maybe say a quick comment. I think that I would agree with Alison. It's not about despair. I think it's about that combination. And to what Max was saying, it's about using your own creativity in deploying these tools. So I think it's that combination of liberal arts and a technical degree. So it's, if you're an engineer, go take an art class. It's that kind of thing. Because I think you're really only limited by your own creativity. And ultimately, this is just linear algebra. This is just linear algebra. So
On
just
steroids.
on steroids. That's right. Take Max's class.
So, I mean, just want to add on what you said is, partnerships will be very important to solve these problems moving forward. Government does not have the bandwidth to develop these capabilities. And on the other side, companies may have the capabilities to develop some of this, but they do it without a full understanding of what is really needed in the government, because they don't, they create products they think they're useful. And of course, I mean, we know that they would need to do market discovery, customer understanding, and all of that, but not always they do it properly. But I want to add another element that it would be important. So it's a three-way partnerships that I'm envisioning, and the third element is academia. Because academia is where the research is happening, is where we have our best and brightest upcoming researchers who are willing to work hard to help solve some of this big problem. And that's why I go back to that model, the NSF-IUCRC model, which is exactly a partnership between three types of entities. The government, who has the needs to solve these bigger problems, the industry, which has the capability of working on those, and the bandwidth and the technical infrastructure to develop software, to develop hardware, and universities, which can provide the subject matter expertise and the talent to help solve some of those problems. As I always said, we do research, but we don't develop software. We don't have a CI/CD pipeline. We don't have a way to package software and make it work for the customers, but we need to partner with industries to make that happen. And one example, in addition to NSF-IUCRC, that is very useful in that is most DARPA projects. DARPA projects are typically very large projects, very well grounded in real problems that DARPA wants to solve. They typically need big companies to respond to those call for proposals, because it's those programs are heavy in terms of deliverables. NSF is happy if we produce a bunch of papers. DARPA needs deliverables, software. And companies can do that. We can help them in inspiring the research that will drive the development of those products, but they need to do the actual work of coding and packaging the software for delivery to DARPA. And that typically works great. I mean, I've been part of a couple of those things, and typically works great. And typically DARPA brings together different companies working to solve that single bigger problem they want to solve. And typically the results are very interesting.
So I'll just wrap it up because I think we're a minute over. But ultimately, when you think about cybersecurity, we are already in a hot war. And so there's a lot of discussion going on at a higher level about what's going on with the transatlantic relationship with NATO. And then, of course, the saber rattling that's going on in the Indo-Pacific arena. But they're already here. They're already sitting on our networks, endpoints that we have that we did not account for many, many years ago, to include your toothbrush, your smartwatch, your car. There's all these things now have connected to any network, including ones that were thought to be air-gapped. So none of that stuff kind of exists anymore. So given that this is the new environment that we live in, just have like a recognition that moving ahead, you are essential to national security. The things that you built will maintain are essential for everyday life. We rely on them, even the military. A lot of the things that we have are dual use. It's not kind of like a one-off, unless it's a ship, a plane, or a defense article. And so moving ahead, being able to leverage P3s over the costs, risks, and benefits are going to be essential. Not one person can do everything. Not one company, even in the federal government, can't do this with the resources that they have. And so, moving ahead, I think it'll be important, again, to kind of circle back to the wonderful resources that we have here at George Mason, to be able to leverage that in your quest to continue to be more effective, efficient, and successful in your careers. And really appreciate the time today. AI, don't be afraid of it, but take some time to get to know it and understand how it can leverage you and the work that you're doing to kind of reduce some of the timelines that put you on the wrong side of the ledger, as we discussed earlier. So thanks again.
Well, thank you very much. I think we are at the top of the hour, so we wanted to close the panel. But if you have any questions, please come to see us and share your thoughts and the questions. Thank you so much. Thank you, Matt.